Audible,
Yeah, sir. Yeah.
screen visible.
Yeah, sir. It's visible.
Today is 11/11/2025. Correct. And we are done with alcohol. We did oxidation of alcohol. Now we are doing reaction of phenol. How phenol react? So we are doing a reaction of phenol. And when we are doing this, one of the very popular reaction is electrophilic substitution reaction. You know this is one of the reaction you have in every chapter. And 100% you will get one question in your coming test also from
Mhm.
electrophilic substitution reaction. 100%. Why? Because there are many unique things in this reaction compared to haloalkane halogens. What
Yeah.
happened in haloalkane halogens? What happened in haloalkane halogens electrophilic substitution reaction?
In electrophilic substitution reaction, sir.
Yes, in haloalkane halogens.
In haloalkanes, haloarenes, yeah, sir. This thing, halogenation of chlorobenzene and all,
Halogenation, yes. So most
and
of time
then
you will see ki ortho and para directing and para is more stable. That was the simplest thing,
yeah, sir.
right?
Yeah.
Here electrophile means electron loving. It means positive molecule will enter. And when positive molecule added to the benzene ring, then it will attack on the molecule that have more electron, negative charge, right?
Yeah, sir.
And to get more charge, what should be the nature of OH? Should it be like
Yeah,
plus
sir.
I effect plus R effect? Which one it is showing? OH of phenol, inductive
Uh,
effect and resonance effect.
Sir, it's a resonance, no, sir.
Yes. In resonance, which one? Plus R or minus R?
That I don't know. Sir, is it? No, sir. I'm not sure.
It show plus R and minus I effect.
OH group in phenol. Okay, sir.
Yes, very, 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 very important. Okay, so how? OH, show five resonating structure. When OH donate, this oxygen contain one lone pair electron. When these electron move, they can be present on ortho position and para position, right?
Yeah. Yeah, sir.
And resonance effect is always way stronger than the inductive effect.
Yeah, sir.
It means this OH group will activate the ring for electrophilic reaction because now electron will be available on ortho and para position.
Yeah, sir.
But you will usually see ki it do activate, but effect will be more.
Yeah.
And that's why you sometimes you see ki there is uh, multiple substitution of the molecule. Usually what should happen? Only one molecule at a time,
Yeah,
right?
sir. Yeah,
But
sir.
here
Yeah.
many molecules can be added at the same time. Reason high activity due to the resonance effect of the
OH group.
phenol group. Yes,
Yeah.
because of the OS group, there is very high resonance effect plus R effect, and because of this plus R effect, ring will be activated and it can easily react with the different molecule. And there are multiple methods. First method is nitration. Nitration means in this case, nitration electrophile will be NO2 positive.
Yeah, sir.
This is electrophile because topic name is electrophilic substitution reaction. Electrophile will be added to the ring. How? Because when you have HNO3, it will break down into NO2 positive and OH negative.
Okay.
Got it?
Yeah,
So
sir. Understood.
electrophile is NO2. Now NO2 will be added on ortho and para position. Correct? But
Yeah,
remember,
sir. Yeah.
this phenol activates the ring too much and many NO2 can be added on ortho and para position. To avoid this
Yeah.
first situation, if you take dilute form of HNO3
Yeah, sir.
plus low temperature how much? 25 degrees Celsius room temperature. Then it
290.
will give you 298, 25 degrees Celsius, right?
Yeah, sir. Yeah, sir.
So it will give you only one product, only mono substitution. Example
Okay.
here you have dilute HNO3 and ortho and para product will form. This is para,
Major will be para.
correct. So this is the common thing. What is special this time in this reaction is that here we are using dilute form. Why? Because if you take concentrated form, too many HNO3 molecule, then multiple NO2 will be added on the ring, right?
Okay. Yeah.
This is the para product, para nitrophenol,
Yeah. Orthonitrophenol.
and this is ortho nitrophenol.
Yeah.
What is special? Now question can be asked how to separate these two molecules.
Yeah, sir.
How to separate these two molecules? And answer will be
Steam
C.
distillation. Yeah.
Exactly. Steam distillation is the method where we can separate these two. What do you mean by steam distillation? How it happens?
So steam distillation is this thing. How do you tell?
Hmm. Now you have
Yeah, sir.
tell me.
Yeah, sir. It's basically separation technique
Hmm.
which separates these things, sir. Organic compounds
Uh,
with isolating temperature.
hmm.
So then the volatile compound is vaporized out,
Hmm.
and then the vapor is then condensed and collected.
Hmm. So what will happen in this case? You have one ortho and para product. You know, in one case there will be hydrogen bonding within the same molecule, correct? So here you will have intramolecular hydrogen bonding, correct?
Yes.
Bonding, hydrogen bonding within the same molecule, within same molecule, intra. Inter means between different molecule. How? Example here you have this para product. Then this para product will react with the ortho OH of the another molecule.
Okay.
Okay. So example, if you take OH here, this is para NO2. So what will happen in this situation? Hydrogen bonding is happening, but
Yeah.
between different molecule. You call this as intermolecular hydrogen bonding.
So intra is between the same molecule, and inter
Yes,
is the separate.
correct. Intra will happen in case of ortho or para,
Ortho,
and in case of intermolecular,
intermolecular.
para will have.
Yeah.
Now tell me which one will be more volatile?
Sir, is it ortho?
Yes. Ortho is easily steam volatile. What does it mean? It means if you heat this compound, it can easily form vapor compared to the para molecule. Here, this molecule is less volatile. What is the reason?
Yes. Sir, this thing, sir. Symmetry, higher boiling point.
Yes, higher boiling point. And what is the reason of higher boiling point? Because two molecules are so strong,
Yes.
breaking bond between them will be difficult.
Yes.
Any doubt?
No, sir. Understood.
But this is for the dilute form. If you have concentrated form, what will happen?
Sir, all the NO2s will be attached to the same phenol.
And why?
Sir, because our temperatures are high and then we take concentrated form, so it is activating. That's why phenol is an activating, highly
Yes,
activating.
phenol is highly activating, and when we take concentrated form means NO2 availability is also high. And due to high availability of NO2, you will see it will be present on ortho as well as para. Correct?
Yes.
What is the name of this compound?
Uh, 2 comma 4 comma 6 trinitrophenol, picric acid. Yeah.
Correct. 2, 4, 6 dinitrophenol.
Phenol.
Correct. But NCERT mentioned that ki nowadays we can make picric acid by another method. So what is that method?
Don't know.
First, you
Yeah.
take phenol,
Okay.
same starting point, phenol. This phenol will react with the concentrated H2SO4. So if you react with the concentrated H2SO4, what will happen? What
So
will
the same.
happen?
Uh,
Sulfonic acid will be added at
oh yeah.
ortho position
SO3H. SO3H. Yeah, yeah. Remember, remember.
and para position.
Yeah.
Now, if you add HNO3 in this, you will see same picric acid,
Okay.
but here productivity is more. Got it?
It's produced in higher.
NCERT do
Yield is high.
yes, yield is high. Here we can say yield is slightly low. Here yield high. Any doubt?
No, sir. Understood.
मेरा तो है कोई just give me 1 minute.
Yes.
Hmm, मेरा तो पहला है बात हुआ को नहीं. So what is happening, which is special in case of phenol and did not happen in other reactions?
So don't like
Mm, multiple are attaching with the ring. Just example in case of haloarine, you saw there were only one molecule.
Yeah, sir. Sir, I'm not able to hear. Sir, I'm not able to hear, sir.
Am I audible, Sinmay?
Yeah, sir. Now you are.
Uh, so police substitution is a special thing in case of the phenol. If you want mono substitution, you have to reduce the concentration. It means you have to dilute. Same thing you will see everywhere in this reaction. Example, if you take halogenation, it means if you take low temperature, then phenol will react with the halogen. Any halogen example, you can take bromine, chlorine, it's your choice.
Yeah.
But as we mentioned, we have to reduce the activity. That's why we are not taking water, we are taking CS2. In CS2, activity will be low. And even temperature is also low, 273 Kelvin. It means 0 degrees Celsius, right?
Sir,
Makes
what
sense?
is CH2, sir? I forgot. CH2.
Carbon disulfide.
Ah, yeah. Yeah, sir. Yeah.
So what is happening in this CS2? Whether you take CS2 or even chloroform, these
CH.
are the low polar molecule. They are not allowing to make positive and negative ion. Okay, so we
Yeah,
call
sir.
them low polarity solvent.
Yeah,
Got
sir.
it?
Yeah, sir.
Example, if you take water here, then in case of water, bromine can easily break down into Br positive and Br negative. And you know further process. In this case, para product will be the
Yeah.
major product.
Orthobromophenol, parabromophenol.
Uh, so what I am trying to convey you, reaction is not important. In which condition reaction is happening is special in phenol chapter.
Yeah.
In
Understood.
haloarenes, it was a normal situation. Here, low polarity solvent and 0 degree Celsius temperature, and examiner is more concerned about this situation. That's why there is a high chance this kind of reaction can be asked.
Yeah, sir. Even I observed in CT, it's not about the final thing, sir. They mostly ask in what condition and solvent use, temperature, and all those things.
Perfectly. So you
The
have to
catalyst and all.
understand what is the
Yeah.
unique thing in the reaction, right?
Yeah. Yeah, sir.
Unique. Unique reaction is always asked, and not only here in every situation, whether it is
Yeah.
physics, chemistry, or math, unique thing is asked. But if you take Lewis acid, normally you will see कि in haloalkane you take Lewis acid. If you take Lewis acid here, what will happen?
Uh,
Lewis acid is like FeBr3 or FeCl3 like that. What happened in this Lewis acid? This FeBr3
yeah.
is polarizing molecule. See, CS2 or chloroform is low polar solvent. So
Okay.
they do not polarize the bromine or phenol, right? But
Yeah, sir.
Lewis acid can polarize the halogen molecule.
Oh,
And if it polarizes halogen molecule, it means it can easily produce bromine positive ion and poly substitution will happen. Got it?
Yeah, sir. Got it.
But interesting part is phenol is so much active. You don't even need this lactic acid.
Yeah.
You don't even need this lactic acid. Even in its absence, phenol is still highly active.
Yeah.
Even in absence of FPBr3, this phenol is highly active because this is the real nature of the phenol. It is always highly active. What is the reason, Chinwe?
So because of OH group, plus R is greater than minus I.
Exactly. You have to write resonance effect plus R.
Resonance. Yeah.
So when it react with the bromine, what will happen? Poly substitution will occur. Okay, so question will be asked if bromination occur in case of water, what will be the product? If bromination occur in presence of CS2, what will happen?
Yeah, sir.
This is what they're going to ask.
Yeah. In this
Got it?
PU test report, sir, they asked one question now. Why are haloarenes less active towards nucleophilic substitution reaction?
Is it?
Yeah, sir. It was very easy.
There are four,
Same.
5 points we wrote,
Yeah. Resonance
right?
effect, partial double bond character,
Exactly.
instability, that, yeah, all that.
Perfect.
Yeah.
Okay. So, and these two reactions are important, and let me tell you, you will definitely get one question from this electrophilic substitution lesson 100%. Okay.
Yeah, sir. Yeah.
So, what we have what we have studied from this, let me summarize in a very small part. If you have phenol, and if phenol is reacted with the dilute HNO3, then only one product will form, is whether it is ortho or para molecule. Correct. If
Yeah, sir.
concentrated, then multiple molecule will form. Correct.
Yeah,
Here,
sir.
here,
On the
and here.
same. Yeah.
If you take CS2 or chloroform with the bromine, only I will write one thing to make it easy. Mono substitution, poly substitution. Here, mono substitution. And if you take same thing in presence of water, there will be poly substitution done. Right? Multiple.
Yeah, sir.
Poly means multiple molecule. Mono means only one. And in case of mono, you have ortho product and para product. Ortho is more volatile and para is less volatile. Why? Because in ortho you have intramolecular hydrogen bonding. Here,
Hydrogen bonding.
intermolecular. Topic
Intermolecular.
is done.
Yes.
Right? This is the summary of the topic. Intramolecular, more volatile, easily you can hit. Intermolecular hydrogen bonding, strong bonding, you cannot make it volatile.
Yes. Yeah.
Even in next, from next four reaction, two are extremely popular. Kolbe and Reimer Tiemann. Again, you will get one question from either Kolbe or Reimer Tiemann.
Yeah, sir. Even our teacher was telling in JEE last year, some 9 questions came from different sessions. Only from Reimer
Different
Tiemann they
session,
asked.
how?
Only from
This is
yes,
very,
sir.
this is very, 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 very popular. And
Yeah.
whenever you are doing reaction, you should know the basic thing. What is the reactant,
Yeah,
what
sir.
is the product, and how reaction happen. Example, in this reaction, phenol react with CO2, and when phenol react with the CO2, the COOH will be added. What is the name of this compound? Salicylic acid.
Salicylic acid. Yeah.
So question can be asked directly. Salicylic acid from phenol is formed by using which chemical?
Yeah.
Like this. So what
Yeah.
will happen in phenol if you take NaOH, then you know water will be removed out
Yeah, sir. Phenate will be
and
sodium phenate.
O phenoxide
Oh,
ion will form.
yeah, sir.
Now it will react with CO2 and then you have to remove the sodium as well. That's why in second step you will add S positive ion because you will remove Na positive.
Yeah, sir.
Got it? This is
Yeah, sir.
Kolbe reaction. But sometime if they want to ask difficult question, they can make it more complicated. They can ask if you have phenol and you have phenoxide, which one is more reactive?
Uh, yeah.
Phenoxide ion is more reactive than phenol.
Why, sir? Because it's an intermediate form.
Yes, one is intermediate, like ionic form is
Yeah.
more reactive compared to the non-ionic form. One reason is this. Second, you know, कि in phenoxide there are more resonating structure.
Yeah.
Even phenoxide ion is like highly acidic compound, more resonating structure compared to the phenol, not in the number, stable molecule are more.
Yeah, sir. Yeah.
Okay, that's why here you are taking CO2, right? This CO2 is a weak electrophile, not strong. What do you mean by weak electrophile? It is not like proper positive ion is produced like NO2, like halogen. Proper positive ion is produced and then this electrophile will attack, right? CO2 is
Yeah.
very weak electrophile. How do we know? Because in CO2, octet rule is completed,
Yeah,
right?
sir. Yeah, sir.
How electrophile and nucleophile is formed? How it is going to attract another electron? If it is electrophile, it will attract electron. But why CO2 will attract electron? Octet rule is already completed.
Yeah, sir.
Understood?
Yeah, sir.
If you are
Understood.
already stable, why you will attract more structure?
Yeah, sir. Correct.
So how this reaction is happening? First, we have to convert phenol in the phenoxide ion. By the way, phenoxide ion is this with benzene ring. This is highly reactive. Now it can react with the CO2. But if you directly take phenol and react with CO2, it will not react easily.
Yeah.
Okay. And remember, this salicylic acid is the main product.
Oh, there are more products also.
Yeah. In organic reaction, there are multiple products always.
Okay.
But this is the most stable. Can you tell me what is the name of this compound?
Uh, sir, is it 3-hydroxy benzenoic acid?
3-hydroxy
2, sir. 2-hydroxy benzenoic acid.
benzoic acid. Yes,
Yeah.
very good. Because remember, COH is top priority compared to OH. So you
Yeah.
will always start from this and then this, according to IUPAC. That's why you know it will be 2-hydroxy benzoic acid. Is benzoic acid IUPAC name or common name?
Sir, IUPAC name.
Both.
Salicylic acid is common. Okay.
Both. No, no, I'm asking benzoic acid, not 2-hydroxy benzoic
Oh
acid.
yeah, benzoic acid is, yeah, both. Yeah.
Both. It it is IUPAC as well as the common name, right? So Kolbe is easy. Coal, what is coal? Carbon.
Yeah.
Kolbe. We will do one thing. At the end of the organic chemistry, I will give you short PDF of all the naming reaction, which is really important for exam. And we will write 3-4 times, so you cannot miss any.
Yes.
Okay.
Yes, sir.
Next, the most popular. Remember, most popular reaction in organic chemistry. Most popular in organic chemistry is, you already mentioned this, is Reimer Tiemann. You can never forget this reaction. You will always get in question. Always means always. Okay. That's why
Yeah. Yeah.
I made it specially for the red color, most popular reaction of the organic chemistry. And mm, in 90% case, they will never ask you ki write Reimer Tiemann reaction. No, they will never. They will give in the indirect form ki what will be the product if this is happening.
Yeah,
Let
sir.
me write reaction first. We know we are doing phenol, so definitely phenol is the reactant. It's easy.
Yeah.
If you know na, Reimer-Tiemann is given in the phenol chemical property. So it means
Yeah.
phenol is the reactant. Even in
React.
Kolbe, phenol is the reactant. Correct?
Yes.
It react with the chloroform and also take aqueous KOH NaOH. Remember,
And
if you take aqueous and alcoholic, it make huge difference,
yes, sir. Yes, sir.
right?
Yes,
Huge
sir.
difference. So what happen in this case? You will see ki this CCl2 will be added here. That will be the one of the major intermediate. In this reaction, what will happen? OH same at ortho position.
Okay.
CCCHCl2 will be added, and this name is also important. Benzyl chloride. What is the name of this compound? Benzyl chloride. Okay, benzyl chloride. And
Yes.
because you are also reacting with NaOH, you have to increase reactivity. To increase reactivity, you make
Na
phenoxide
plus.
ion, phenoxide ion, right? So
Yes.
you have benzyl chloride. Question can be asked: benzyl chloride is formed in which reaction?
Yes.
Reimer-Tiemann. What is the intermediate in Reimer-Tiemann? Benzyl chloride.
Yes.
Okay. What happened because of the water? Let me show you this, like what happened along with the water. Here you have two chlorine, one chlorine, second chlorine. If you react with the water, what will happen? Two molecule of H2O. In
Yes, sir.
what will happen?
CHO. Yeah. OH.
Because 2HCl will be removed, correct?
Yeah.
If, if you heat this, what will happen? H2O is one of the stable molecule. H2O will also be removed.
Yes.
So can you say it will be O negative Na positive with CHO, correct? If you add
Yes.
H positive ion here, what will happen? CH.
Sir, what is the third this thing compound called? Sodium phenaldehyde.
Third one, which one?
Sir, after the formation of intermediate.
After the formation of intermediate, salicylaldehyde. Aldehyde, na? Salis, because ortho position.
No, sir. Before that. Before that. In the intermediate, just before that.
This one,
Yeah, sir. Yeah, sir.
Yeah, this is aldehyde, but in the ionic form.
Okay.
Then when you add as positive ion, it will become phenol. So this is also salicylaldehyde. Salicylaldehyde, right?
Yeah, sir.
What should be the name of this compound?
Uh,
2-hydroxy
2-hydroxy benzaldehyde.
benzaldehyde, right? So you can
Yeah.
write this also. 2-hydroxy benzaldehyde.
Sir, what is so special about this reaction, sir, that it is so many times asked?
Uh, Even I am surprised ki what is the specialist about this reaction. Uh, but they always ask, always
Yeah.
in every reaction, because this is one of the most popular form to make salicylaldehyde. Salicylaldehyde is one of the popularly used compound.
Yeah.
So what you should know, what is the reactant? Chloroform.
In the presence of aqueous NaOH.
Aqueous NaOH. Then benzyl chloride is the intermediate form here.
Yeah.
Okay. And after intermediate formation, aldehyde will be attached on the ortho position. Then and
Yeah.
salicylaldehyde will be formed. Now do one thing right now. You write both these reaction Kolbe as well as Reimer right now.
Yeah. Right.
Our teacher also told one popular thing. You know, when you take chloroforms in math,
Yeah, sir.
you know what is formed out of these two? CCl2, dichlorocarbon. This is the molecule formed from the chloroform, dichlorocarbon, because this is what added here. CCl2 is produced from the combination of the chloroform. This
One
is
more thing that
dichlorocarbon. Our teacher gave this in our notes.
yeah,
Yes,
sir,
one
in our
more thing.
class, yeah, they told one more thing. This chloroform is stored in colored bottles because it will, when exposed to sunlight, it will decompose to form phosgene, which is highly poisonous gas.
Correct. And this is also popular reaction, like they usually ask in exam. Did they
Yeah.
ask today? Yesterday?
Yeah, sir. Yesterday they had asked it.
Huh. So there are two things. You always keep the bottle in dark.
Yeah, sir.
One. Second, you always keep the bottle full,
Yeah.
right?
They had asked this
Because
in type of assertion and reason, sir.
is it?
Yeah.
Yeah,
Chloroform is always stored in bottles, closed bottles, because it gets decomposed to form phosgene, which is highly poisonous gas. So both are correct.
exactly. Yes. But I want to ask one thing.
Yeah, sir.
Why Kolbe and Reimer Tiemann reaction are forming the ortho product? You know, para product is more stable.
Stable. Yeah. I'm not sure, sir. I was about to ask that question.
Answer is intramolecular hydrogen bonding.
Okay.
Intramolecular hydrogen bonding is strong in ortho. Okay.
Yeah, sir.
I will write this question. Why ortho product is more stable in Kolbe and Reimer Tiemann reaction? Because it come into our mind कि para product is always more stable compared to ortho. Why we are forming ortho as the major product? Answer is
Yeah.
intramolecular hydrogen bonding. Ortho have strong intermolecular hydrogen bonding.
Yeah, sir. I'm done.
Send me.
Yes. Yeah, sir. I try to do it without seeing, sir. That's why it's a little messy.
Very good. No problem. This is what we need. You do without phenol and NaOH, sodium phenoxide. Sodium phenoxide, not phenate.
Oh, okay.
Sodium phenoxide.
Phenoxide. Yeah, sir. I'll change it.
Yeah. So salicylic acid, hematite, chloroform aqueous, benzyl chloride. Okay. So
Yes.
these are the two very popular reactions. That's why we took time. Other part is easy, but they are used in the conversion sometime with the zinc. Example, if you take phenol, we are already done with this reaction. And
Yeah, sir.
it react with the zinc, what will be the product?
Benzene,
Why?
and zinc oxide. Sir, because in it's heated, sir, the OH will get reduced to
Zinc oxide is stable compound.
stable compound.
And last is oxidation.
Oxidation.
If you take oxidation of phenol, what will be the product?
Sir, benzoquinone.
Benzoquinone. Remember one thing. If you take normal alcohol,
Okay.
then it will form aldehyde, right?
Yes, yeah.
If you take secondary alcohol,
Ketone.
then it will form ketone,
Yeah.
right? Here, phenol, where OH is present, it is secondary, attached to the secondary carbon. This is secondary carbon, right? And if it is attached to the secondary carbon, what will happen?
Ketone will be formed.
Exactly. Ketone will be formed because of the oxidation. And for oxidation, you need oxidizing agent. That's why, like Na2Cr2O7, it's like K2Cr2O7.
Yes.
But for oxidation, you need effort. Effort means H2SO4 should be added. And then what will happen? Multiple oxidation will happen.
Yeah.
We have seen this somewhere.
Sir, in the
Benzoquinone.
thing, sir, in the what do we tell? Uses of haloalkanes, haloarenes, I think so. Something it came over
Correct.
there.
Correct. Benzoquinone. Very.
Benzo- Yeah.
So this reaction is not that important like Reimer Tiemann or Kolbe, but they can ask direct question from this. Benzoquinone. Ki, here it look easy, but after completion of the complete organic chemistry, you'll feel ki, okay, I'm not sure. If oxidation happen, what should happen?
Yeah.
Right? So
Is this the
with
only
this
condition, sir, or oxidation of phenol can also happen only in air?
oxidation and reduction only happen in air. Oxidation mostly happen in air because oxidation means addition of oxygen.
No,
And
sir.
in a
This reaction in phenol, do we necessarily have to use the reagents H2SO4 and oxidizing agent
to
to
proceed
get?
it further because H2SO4 is a strong acid. So it will proceed to form the phenoxide ion, and phenoxide ion can easily convert into the benzoquinone.
Yeah. Okay.
Okay, makes sense.
Yeah, sir.
And so with this, we are done with alcohol and phenol both. Everything is done.
Yeah,
Not
sir.
today, but tomorrow we will make a summary. Instead, I would say one thing: you make summary.
Yeah, sir. Okay.
It will be more beneficial if you make summary of this chapter. Okay,
Sir,
because you
ether.
will remember. Ether will do tomorrow. I'm saying ki
Yeah. Till
you
now.
make
Also.
summary from
Yeah.
whatever we did because this is really important.
Yeah, sir.
What is the subjective portion? 25 marks, na?
Yeah, sir. Same. This chapter for 25 marks and same chapter for 60 marks.
So out of 25 marks, you can imagine ki at least 18 marks will be asked from this portion only.
Yeah, sir. Yeah. Pakka.
Pakka 18. So that's why in ether there are mainly two questions. One is
Only
Williamson
something came
synthesis
real.
pakka,
Williamson's ether.
Williamson synthesis one pakka question, and second is the if it react with HI, what will be the product?
Ah, yeah, sir. Yeah, sir.
Nothing else you get because if you take any sol and electrophilic substitution reaction, everything is normal, nothing
Yeah.
special.
Same,
Okay,
same. It is.
so that's why whatever we did so far is important. Today you will finish summary of this chapter and send me before you sleep.
Okay.
So tomorrow we will finish this chapter thoroughly. Day
Yeah.
after tomorrow, we will solve minimum 50-60 questions in class.
Yeah, sir. Sure.
So it means chapter will be done for CET, board, even mains. Are you done with the mains application form?
Not sure, sir. Not yet, sir. I got the enrollment number today. Today evening I'll do after class.
Enrollment number means?
Sir, during filling of the J mains form, they'll ask enrollment number and SATs number, sir. Which college has it? The information.
Is it?
Yeah, sir.
Okay. So
So
very you have to.
we have to fill it in the J mains form. So today they gave. So today or tomorrow I will do it.
And what is the last date?
Sir, I think so. December end.
December end.
Yeah, at least till mid
Oh,
December it will be there.
okay. Because I want you to do well in JEE mains also. Okay. Because you
Yeah.
can do this. Methanol. Methanol, like this is more theoretical part, to be honest. What should be the formula of methanol? This one.
CH, which
What is the another name of this methanol?
methyl alcohol.
Yeah, this is methyl alcohol, common name. What is the another common name we use? Wood spirit.
Wood spirit. Yeah.
Have you seen people sometime apply spirit on the wood that have very bad smell?
Yeah, sir. Yeah, sir.
So that wood spirit it is. How it is produced? If you do destruction distillation of the wood, you can produce this. Produced by destructive distillation, it means at very high temperature. If you heat this
Yeah.
wood, then you can produce it. Correct? So this question can be asked. See how methanol is produced. Destructive distillation of wood, it means very high temperature. But how we can produce it commercially from carbon monoxide? So if you take carbon monoxide, react with the hydrogen.
Yeah.
So what will happen? Of course, product should be methanol because that's what we are preparing. What could be the question? Question is what are the reactant to produce this? What is the name of carbon monoxide and 2H2?
Sir, carbon monoxide and
2H2 hydrogen.
water gas. Water gas.
Very good. Water gas or synthesis, yes.
Yeah.
Very good. Where you read this, I taught you or you got this idea from this class teacher?
No, sir. They were just revising, sir. The time I got.
Okay, very good. Now you need catalyst to proceed this reaction. Zinc oxide and chromic acid,
Yeah.
right? But this will happen at very high temperature and pressure. Very high temperature. Why? Because this molecule, when there is a high temperature, they will compress. And high temperature for the reactivity, right?
Oh,
High
yeah, sir.
temperature for the reactivity. So 200 to 300 atmospheric pressure and 573 to 673, almost 300 to 400 degrees Celsius. Just imagine 300 to 400 degrees Celsius. It is too much, right?
Yeah, sir.
So question can be definitely asked from this. And we call it as catalytic hydrogenation. Why? Why we call it as catalytic hydrogenation?
Don't.
Because in
Because.
presence of catalyst, you are adding hydrogen.
Yeah, sir. Yeah.
Catalytic means in presence of catalyst. Hydrogenation means addition of hydrogen.
Yeah, sir.
So in presence of hydrogen, you add catalyst. What is the name of the catalyst? What is the name
This
of catalyst?
The name I don't know, sir.
zinc oxide and chromium
Chrome.
oxide.
Chromium. Oh, I thought
And
zinc.
this is the basic information about like how to produce methanol. They can ask what are the properties of methanol.
Yeah.
Seriously, in only in the board, not in CT. What are the properties of the methanol?
Yeah, sir.
Do you think methanol is colorful? Yes.
No, sir, it's colorless liquid now.
Yes. Colorless liquid because if we are applying spirit, it means it is liquid,
Yeah, liquid.
right? Can we boil it easily compared to water?
I don't think so.
Yes. See, you are not supposed to remember the number, what is given in NCERT. What you are supposed to do, it can easily get boiled compared to water. Because for water, what is the boiling point? 373, 100 degrees Celsius.
Yeah, sir.
Here 337, right? Is it poisonous?
Yeah, sir. It's
Right.
highly.
It is highly poisonous. And if it is highly poisonous, what happens if we take in the small quantity
Mm, some
and
body dis
large quantity?
large
What?
quantity, it's death.
Large quantity death and small quantity
Some illness,
blindness.
blindness.
It can cause blindness. And now you can understand it is highly poisonous. So sometimes what people do, example, you have a factory
Yeah,
where
sir.
you produce ethanol, okay, for commercial purpose, not for the liquor purpose, commercial purpose. And you know, truck driver can sell the truck alcohol in the cheaper price, but this is very high quality alcohol,
Okay.
and don't want you don't want to misuse it. So what will you do? You will add some harmful chemical in the alcohol, in ethanol, that is methanol. Okay.
Yeah.
Once it reaches to the destination, you will give them chemical formula ki how you can reverse it. You can make again ethanol. Make sense?
Yeah, sir.
So that's why, though it is not given in the NCERT, used to denaturate
So that question was once asked, sir. Denatured
ethanol.
alcohol. What is it?
Denaturation means you are destroying the nature of ethanol. Ethanol should have only C2H5OH, but if you add something else, that is denaturation. You have denaturation of alcohol in the next topic, ethanol.
Yeah.
Okay, so it can denaturate the ethanol, and if this truck driver tried to consume it or try to sell it, people can die. That's why he will never use it, right? This is the normal physical property. What are the use of it? There must be some uses. That's why we are producing it.
Yeah, sir.
What could be the possible use, in your opinion?
So first is obviously alcohol beverages.
No, 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 no. Never use in the alcohol beverage. That is
Methanol.
ethanol.
Yeah, methanol uses. Yeah.
Solvent.
Solvent, yeah, sir.
Because it is liquid, it is solvent in paints.
Yeah.
And uh,
Sir, I think it is
also,
used for denaturation of ethyl alcohol.
yes, denaturation, of course, in case of varnishes. So, what is varnishes?
Sir, it's applied over paint for preventing it from rusting.
Yes. And that's why you will see ki whenever you paint the anything, na, there is always very bad smell, like you can't tolerate easily, right?
Yeah, sir. Yeah.
And it can also use for the formaldehyde formation. What is formaldehyde?
1 degree alcohol. Yeah, sir. Yeah.
Because you know, if you do oxidation of the
For formaldehyde, we
methanol,
get alcohol. Yeah.
formaldehyde will be formed. Done.
Yeah. Yes.
Last topic, and then we'll be done with the alcohol phenol completely. Like 90% of the chapter will be over.
Yeah.
Ethanol. Have you ever tasted?
No, sir, never.
Never.
Yeah.
Like one thing I really like about your family in general, your father,
Yeah, sir.
is that he is very simple and down to earth person, and like do not have any bad quality. He
Yeah, sir. Not even one. Nothing.
like everybody, like not everybody, many people there are some smoking, drinking,
Yeah.
or like they shout,
Yeah.
but he's very calm, composed. It's like he look like guru, like very
Yeah.
peaceful person, calm, composed. Is this
Yeah.
true?
Yeah, sir. It's in case of our entire family. Like in from her father's side, there are four siblings. No one touches alcohol, smokes, nothing, sir. No bad habits.
Yeah, and like he's very religious or spiritual, I guess.
Yeah, sir.
And like I would say ki you are very lucky, man. Very lucky.
Yeah.
Like not many people get this kind of father who himself are the good, you know,
Yeah, sir.
good source of motivation. You don't need to go out and seek he. And when he supported you for the games, na, I
Yeah,
was
sir.
very, very happy
Yeah, sir. That's true.
because initially I thought he maybe he'll be like whether you should like go for the games or not, but he was very supportive. Yes, you can go, right?
Yeah, sir. He was.
He was, and even sometime I talk to him now.
Yeah,
He's
sir.
not like he want great things from you. He
Yeah.
read this. I want 99% marks, 95%. You should get in this. Nothing. Like, does he tell you ki Chinmay, you should get this percent of marks or this thing?
No, sir. He just tells me to put in the right amount of effort. That's all.
Exactly. Not many people do this. Like they expect only result.
Yeah, sir. That is.
They are not bothered about how. And is this true? This is my perception. That's why I wanted to like ask you
Yeah,
based
sir.
on our
Yeah,
conversation. Like he's very like he have very high moral value.
yeah, sir. That's true.
Like, do you feel it in your family? Ki, haan, it's like very high moral value,
Yeah, sir. It's true.
and not many people in this world have this, and that's why when he told me about you, you know what he said? He said, "I trust you." That's all.
Yeah.
And I was like, now it's my responsibility to do better. And I think that is the reason why you are self-motivated. Is it?
Yeah. Because of the trust they have. Yeah.
Exactly. And I told him, ki, sir, he should do exercise, he should maintain overall health. And he was, yes, sir, I strongly agree. And I recommend him, ki, you should go to exercise, do everything, whatever is required. And I was like, man, most of parents, especially
Yeah.
12th class, they'll like, read, 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 read. What you are doing, read.
Yeah, sir.
Um,
Yeah. They
I
run
would say,
behind
ki,
scoring marks.
yeah, they run behind marks. And your father, I think, run behind morals.
Yeah. That's
My
true.
son be should be morally a good person.
Yeah, sir. That's true.
And even I think reason why I'm talking too much because I feel I am the like person who values moral a lot, like integrity.
Yeah, sir.
And he's the one. So it's like I get to vibe with your family, and I think what best thing you can learn from your family. It doesn't matter what kind of person you are, how much you are earning. What is the best thing? To be a moral and person of the integrity,
Yeah, sir. Yeah.
right?
Yeah, sir. That's
Right. Doesn't matter. Even I will never uh, ask you ki why you got this less marks. We will definitely improve, but rather than that, it's like make sure you are enjoying the process.
Yeah, sir. Effort will
Yeah, effort should be there. Let's finish this ethanol.
yeah,
So ethanol, very popular. There are different methods. Commercially, we produce it by fermentation because cheaper.
yeah.
Commercially, we can produce it from the fermentation. Why? Because cheaper. What do you mean by fermentation? Anaerobic
Fermentation,
process.
like they brought that fermentation of molasses. So molasses is non-crystalline product which is left behind in sugar industry.
Correct.
And fermentation, sir, it is fermented by initiating of yeast, and then two
Correct.
enzymes are secreted, which are invertase and zymase.
Huh.
And then this sugar in molasses will convert glucose to fructose in the presence of these enzymes.
Correct. That's true. Remember, fermentation means anaerobic process. Means reaction occur in absence of air.
Yeah,
That's why you must have heard ki people who are making like they make alcohol in their home.
yeah.
Like do people produce in Karnataka alcohol in home?
No, sir, I don't. They don't do it in home.
Okay. So in Haryana, Punjab, it's very common. So
Common, yeah,
they keep jaggery, mostly jaggery here, and
yeah,
they put in a pot for a long time because it should be anaerobic process, fermentation process.
yeah.
So fermentation process from sugar. So there could be multiple source of sugar as you mentioned. It could be molasses. What is molasses?
Sir, it's that product, sir, which is left behind in sugar industry, like a byproduct.
Molasses are like once you get this sugarcane juice, na?
Yeah, sir, the left behind waste part.
Yes, it is molasses. Or it could be sugarcane as such.
Yeah, sir.
You must have heard the government is saying कि we are adding 20% ethanol in alcohol in fuel, right?
Yeah, sir.
So they are saying कि we are getting it from the sugarcane
Yeah,
or
sir.
even in the grapes. What is the reason why we are using this? Why?
Don't
Why we are? Because all three of these contain lot of sucrose.
sucrose.
All of these contain lot of sucrose. And sucrose is the main source of the ethanol formation, not glucose. Glucose will get from the sucrose. So what is the main source? Ultimately,
Sucrose.
sucrose. Chemically, it is sucrose. Got it? And what is the formula of sucrose?
C2211.
Yes, C12H22O11. This is sucrose. What is the formula of maltose?
Of, sir?
Maltose.
Uh, sir, is it same on
Same. Lactose.
lactose? I forgot, sir.
Lactose same. All three are disaccharide we have in
Disaccharide.
biomolecule.
Yeah, sir. Yeah.
So disaccharide means 12 carbon
Yeah, sir.
because it can form two glucose-like molecule. So when this sucrose react with water, it will convert into glucose and fructose, right? You
Yeah, sir.
already told this.
Yeah, sir.
Why we call it as invertage enzyme?
Not sure, sir.
Because, example, is dextrorotatory. Glucose and fructose combined will be levorotatory. So it is ulta inversion. You will have inversion from
Yes,
dextrorotatory sucrose. It will become levorotatory glucose and fructose. And enzyme involved in the inversion process will be invertase enzyme.
okay.
Makes sense?
Yes, sir. Actually,
So what is inversion? You know inversion of configuration in case of
return
SN
configuration. Same
two,
thing.
right?
Yes,
Yes. Same here. You will have inversion of configuration, and that's why the enzyme used here is invertase. Now this glucose will further break down, and this was given in your 10th class also, respiration chapter, right? This
yes, sir.
glucose, when it can produce two molecule of C2H5OH ethanol
Carbon
to
dioxide.
CO2. Tell me, anywhere you can see oxygen in whole process,
No, sir.
that's why it is anaerobic process, fermentation process.
Yes,
Okay, and
yes, sir.
enzyme used here is zymase enzyme. It can be asked ki which enzyme is used to convert glucose into ethanol, enzyme to convert sucrose into glucose like this.
Yes.
Uh, what is the source of wine?
So, what is the source of
Wine,
grape, sir?
grapes. So we use grapes for wine making. And you will ask, sir, okay, all this is happening. From where we are getting this enzyme zymase invertase? Answer is yeast. We yeast will grow on the sugar. This yeast produce zymase enzyme.
Okay.
Got it?
Yes,
Example, if you are taking grapes, so grapes will have a lot of sugar. When you crush the grapes, sugar will come out, and these enzymes zymase will come in contact with the zymase invertase enzyme will come in contact with the sugar, and fermentation will start. Remember, fermentation means anaerobic process. Okay,
okay. Yes,
fermentation means anaerobic process. And how they interact with each other when you crush the grapes. Like grapes are mature, ripened, and when you crush them, what will happen? Sugar will come out,
yes, sir. And that will react.
and this come out sugar will react with the enzyme, and reaction will further proceed. Correct?
Yes,
Fermentation will happen because there is no oxygen involved. Like, do you think we can produce pure alcohol of 100%? Absolute alcohol, we call it as.
I'm not sure, sir. I don't.
Naturally, we cannot. During fermentation process, we can do. Why? Because if you are doing fermentation process, which organism is involved in this? In fermentation, yeast is involved, right?
Yes, sir.
So what happens if alcohol concentration is like 13% or 14%? NCERT here give 14%. So what will happen? This yeast will die and no enzyme will be available for the further reaction.
Okay.
Got it?
Yes,
And if yeast die, all the enzyme like zymase enzyme will not work because yeast is not active. Yeast is not live. Yeast is a organism, fungus. Yeast is a fungus, and this fungus is responsible for the alcohol formation. If you are killing this fungus by producing more alcohol, what will happen? It will die.
yes,
But interesting phenomena. If you see any alcohol, does
yes,
it
sir.
contain only 14% alcohol? Like any liquor?
Don't know, sir. I'm not.
No. You will see in case of rum, alcohol percentage is even 42%.
Okay.
So if alcohol percentage is 42%, then how we are getting 42% because we said we cannot produce more than 14.
Yeah.
Answer is distillation. If example, if we get 42% alcohol, this is possible only by distillation. You know distillation, organic chemistry, right?
Yeah, sir.
Naturally, it is not possible. You filter it and again then you make it pure. Okay. We said ki here fermentation is happening in absence of air. Correct.
Yeah, sir.
What happening if oxygen is present? What happen if oxygen present?
Don't know.
Because we said fermentation means in absence of oxygen,
Anaerobic. Yeah.
anaerobic. But what if oxygen present? Answer is, and this is happen when people try to make desi alcohol in villages, okay, in their hometown. Sometime oxygen can get into the alcohol and it will convert ethanol in presence of oxygen to the ethanoic acid. Oxidation, na? We said oxidation. And ethanoic uh, acid will destroy the taste of alcohol. That's why you will not feel good and if you take ethanoic acid. Though it is not harmful as such, like not much harm in small quantity, but taste you will not get. Got it?
Yeah, sir.
Taste you will not get. And because if you can ask questions, sir, why ethanoic acid is not harmful? Vinegar we consume. Vinegar is also ethanoic acid, right?
Yeah.
You have vinegar in your house.
Yeah, sir. Yes.
You add in food. It is not harmful, dangerous. So
Yeah.
people sometimes think, oh, if oxidation happen, so it will be dangerous. No, it will not be dangerous, but taste will not be good. That's all.
But in small quantities, it is not.
Small quantity?
But it is not dangerous only in small quantities.
Yes, only in small quantity. The property, like how we did in the case of methanol. What were the property of methanol?
It is
Colorless liquid in
colorless
case of
liquid,
methanol.
highly poisonous in nature,
Uh,
and then in small quantities it causes blindness, and large quantities death.
correct. If you compare with the boiling point, tell me, compare to the methanol, ethanol should have more boiling point or less boiling and why?
So it should have less boiling point.
Okay, very good.
No,
Why?
no, yeah. So because branching increases.
The answer is more boiling point because carbon increase, so boiling point
Oh yeah,
increase.
number of carbon increases. Yeah, yeah.
You will not be asked what is the exact number, okay? But you will be
Yeah.
asked boiling point. Do you know? Example, if you take methanol and ethanol, there is no branching, it is straight chain. So
Yes.
you know when number of carbon increase, boiling point also increase. This is the common phenomena throughout the organic chemistry, right? So
Yeah.
here boiling point will be more in case of ethanol. This is what
Yeah.
I've been telling you ki how to correlate with the thing.
Yeah.
Because it, even you can read NCRT, right?
Yeah, sir.
But point is, if you read NCRT, you will try to mug up everything. You will take more time and then you will be, "Ki, why I'm not able to remember this." But here I'll tell what you are supposed to remember more and what is not so important thing and how to correlate. So methanol is solvent, even ethanol is a very popular solvent. Correct? Both are solvent, ethanol as well as methanol. Both are solvent in paint.
Yeah.
Paint industry. That's why sometimes you also get smell of alcohol, right?
Yeah.
But it can be asked for 1 marks. Very, very, very important for 1 mark. Not like this is famous question, but only for 1 mark. Denaturation of alcohol. What do you mean by denaturation of alcohol?
Yes. So the commercial alcohol is made fit for drinking by
Yes.
mixing some other things.
Why?
To make it cheaper, sir.
No,
Then I don't.
I told you. I give you example. You have a factory. One person will, like truck driver, will take it to the another destination. But I told you.
Yeah, sir, but not.
Answer is because people can use it. Right? Like you will have loss if your truck driver is going from the Karnataka to Tamil Nadu and then somebody can loot the truck or he can sell some of the bottles, right?
Mhm.
So you will make sure it is never looted, right?
Yeah.
So how to do this? One thing you can change the color.
Yeah, sir.
If color change, then people will not like it. Example, it is orange color, then normal. But if you make it blue, then what will people think? If this is not alcohol, this is something else, and I will not use it.
Yeah.
So you can make it blue with using copper sulfate. You can make bad smell. If people know the smell of the alcohol, but if you make it very bad smell, foul smell, so people will not use it. How to make foul smell? Using pyridine.
Yeah.
Okay? Pyridine will change the smell. Or though it is not commonly used, but if you add methanol, then it could be lethal. And you tell truck driver ki methanol is added, it is dangerous, so nobody will use it. What should be the commercial method?
Don't know. Not sure.
In your opinion, if you want to make alcohol, how you should make it? Hydration of alkene. Tell me the reaction of hydration of alkene.
Yeah, sir.
What?
Sir,
Do you remember the very first reaction of alcohol formation? Acid catalyzed,
it's anhydrous. Yeah, sir.
acid catalyzed hydration of
It was
alkene.
substance of H2S. It was alcohol.
Yes. So what will happen in this case? If you take CH2 double bond CH2 and you do hydration, what should I add? Chemical.
Water. H plus. H plus ion.
H plus ion H2SO4 as catalyst, right? This is as a catalyst. So what will be the product?
Ethanol.
So,
Ethanol.
so large amount nowadays commercially is made from this. Make it sense and doubt.
No, sir.
So with this, we are done with the majority of part. And now you will be able to solve more question in organic chemistry because you know haloalkane, haloarenes as well as this part. Okay. In next class, we'll finish this. So what is your assignment for today?
Yeah.
Just give half an hour and make a quick notes summary of this
Yeah.
chapter. Uh, which chapter do you have for physics?
Sir, for physics, current electricity.
current electricity,
Yeah.
right? So do some part of current electricity, at least half, right?
Yeah, sir.
When will you sleep?
So 12, 12:30.
12:30. So you will get almost 2 hours for study, right?
Yeah,
So do maximum 1 hour chemistry and at least 1 hour physics. Okay.
yeah,
And send me assignment of both in group before sleeping. Got it?
yeah, sir.
Okay, then. See you. Bye.
Yeah, sir.
Okay.